what GeoServer offers out the box is for as an open source bit of kit, is incredibly powerful. And allows you to get up and running really quickly, and obviously provides those kind of tooling provide people with an off-the-shelf stack that they can use. And I think that's great, and I think that there will always be a place for that. The place that I see serverless fitting at the moment, I think this is probably going to change in the future, but at the moment it's still geared towards a developer focus, sort of a bespoke application. We've got some addresses, and we need to be able to let our customers do a batch process of 1 million addresses a day.
Hello and welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Thomas Holderness, and he's going to be talking us through what serverless geospatial is, what it looks like, how we might get started, and what it might mean for us as geospatial practitioners in the future. I learned a ton from Thomas and I know you will too, so I really hope you enjoy this interview. Just before we get into the interview today, I want to remind you that this podcast is sponsored by OpenCageData. So OpenCageData is a geocoder, and Ed, one of the co-founders of the company, he's been on this podcast a couple of times before talking about his work with geospatial, talking about how geocoding is still a really critical part of the geospatial infrastructure. And I personally have worked with Ed and his company on a couple of different projects, and it's been a really amazing experience. So if you have any geocoding need, I can highly recommend OpenCageData. Check them out. And also, if you're just wanting to play around, they have a few really great demos on their websites, some pretty awesome tutorials. They have integrations to almost every tool you can imagine. So go along, check it out. It's well worth your time. Okay, let's get into the interview. Hi Thomas, welcome to the show. So today we're going to be talking about serverless geospatial, and just before we dive into that, perhaps you could give the audience a little bit of an understanding of your background in geospatial and how you got interested in building serverless geospatial architecture.
Thanks, Daniel, and it's great to be here, and yeah, thanks for having me. So my background in geo goes all the way back to my undergraduate degree. I've got a degree in geographic information science from Newcastle University here in the UK, and then a PhD focused around urban risk, understanding how we can better analyse and measure and map cities and their exposure to extreme weather events. Kind of fell into serverless geospatial working on another project called Peta Bencana, which means risk map in Indonesian, and is a project that still is running in Jakarta in Indonesia, which is creating a real-time flood map using social media. And so one of the challenges with that project is the flooding might happen, say, 10 days a year, but the rest of the year you've got really no one looking at the map. Whereas on the days that you've got large flood events, all of a sudden you've got hundreds of thousands of users that are trying to consume your service. How do you build IT infrastructure to cope with that demand? And that's something that then we also have a similar kind of peaks in demand here at Address Cloud. And so sort of continued my role there and understanding on how serverless technologies can benefit the geospatial community and how we can build great things.
So thanks for giving us a little bit of background. You said a few really important things there that I'd just like to focus on for a second. The first is, it sounds like that some of these applications you're talking about, some of the examples you gave, they had really high peaks and lows. So lots of people or no people visiting the website. And the next thing, we talked about serverless geospatial, obviously. Perhaps we should start there and really give a definition of what is serverless geospatial. What does that mean?
Serverless compute or serverless architectures are simply where you use managed services provided by a cloud provider such as Amazon or Google or Microsoft to host and run your application. So traditionally you would have had a server, and you maybe even had that server in your office or in your server room, and that was where your application ran. And when people connected to your website or to your application, they were accessing information from that server. Following that, we had sort of the advent of the cloud. Instead of having your own server, you'd pay to have a server in someone else's data center, such as Amazon or Google. And now we've moved to a serverless model, which means instead of managing servers in someone else's cloud, you simply say, hey, here's my application, whatever it may be, if it's a map or a database or some computation that needs to be done. And you say, when I ask you to do this, please run this. Please run this piece of code and execute it as many times as I ask for it. And when that's done, stop executing it. And that's really what serverless is all about. It's about having someone else manage your IT infrastructure. And it's basically on demand. It's pay as you go, as we call it here in the UK. You're saying, yep, I'm making a request to the website. Website spins up, gets the information from the database, gives that information back to you, the user, and then all of that infrastructure goes back down so that you're not paying for a physical machine to be on all of the time waiting for those requests.
So just to be clear, there is a difference between cloud computing and serverless geospatial. Is that correct?
Yeah, so serverless computing is sort of the next step on from cloud computing. So cloud computing is kind of this overarching term, and you can do lots of things inside a cloud computing environment. And traditionally, people have been renting machines in the cloud and saying, I want these machines to be on all the time dealing with my application. What cloud providers are now doing is providing technology that can scale up and down automatically so that you don't have to manage it. So you're essentially paying for someone else to manage and deal with all of the nuances of scaling that infrastructure in demand in response to the number of requests you're making. And serverless geo is simply using that the new kind of those new technologies to build geospatial applications and harness that power for applications that have got big data requirements or large numbers of users.
So I'm assuming with serverless geo, we have all those advantages of cloud computing. We have somebody else that is looking after the infrastructure for us, making sure it's up to date, and we have their service level agreement that we can always lean back on and say, well, these guys said they were going to be up 99% of the time, kind of thing. So we have those kind of advantages. And it sounds like what you're saying is that we're paying per execution. Is that correct? So every time a request comes in, I run a function on the serverless geospatial environment, and I pay per execution of that function.
Yeah, that's exactly right. And that execution can be an execution to run my app, or it can be turning on the database to retrieve some data or make a geospatial query. And really what it comes down to, and Werner Vogels from Amazon says this quite well, he says, it's really about your secret sauce. And by that, he means, what's the thing that gives your application market fit? What's the thing that makes your product or your research idea unique? And in geospatial, that thing is often geography. And really, serverless allows us to focus on the secret sauce, so getting the geography right, so getting that address matching really to a really high standard, getting that geospatial query to be really efficient, providing a way for people to send those tweets to report the fact that their house is flooded. And so really managing physical infrastructure and having to control when we scale up servers and scale them down is really detracting from the time and resources I can spend on focusing on that secret sauce, on getting my geography right and focusing on my geo.
I love the idea that somebody else is looking after the infrastructure. It's not one of my strengths. I think this is great. And I love the idea that things can scale up and down. But I can see a few cons with this as well. So in my day job, I work as a geospatial consultant. And for example, we are not, for the company that I work for in Denmark, we're not allowed to host our data outside of the European Union. And I could see that being a problem with serverless geospatial. And also, I can imagine this would be something that'd be difficult to budget for, right? If I'm paying per execution, it's hard to say I'm going to spend X amount of dollars this year on my computing environment because I wouldn't know. There's no set budget.
That both of those issues are completely understandable, but I think that they're challenges that have already been solved. I think that really the geospatial community has this opportunity sort of to see what the traditional IT community is doing in this space and take hold of it and really run with it. So to take your two issues, cloud providers have already solved the problem of where data resides using regions. So we also at AddressCloud have similar constraints where certain data sets can only sit within the EU or within the UK, and you can specify which region, which set of data centers your serverless application and serverless data resides within. So that's really not a problem. You can control that, and you can say these set of functions or this serverless database is only going to run in this part of the world. And then secondly, when it comes to billing, one of the things that it's different. It's a different mindset. And so if you start with a sort of traditional architecture, you'd think about, okay, what's our peak capacity? And then you try to provision for peak capacity, right? So you've got some idea of the number of users that are going to hit your system, the maximum number of users that are going to hit your system at any one time. And so what you have to do is you have to take that and think, well, rather than provisioning for peak capacity, what I can actually do with a serverless model is say, well, I can provide that peak capacity because serverless infrastructure normally can scale almost infinitely, but you know what your top end budget is going to be, because you've already got an expectation that the top number of simultaneous users accessing your service is going to look like. So actually, a serverless model normally works out cheaper, and there are tools out there that can help you compute this, because, for example, during the nighttime when no one's using your application, you're not paying for that managed capacity to be there. And so actually, in some ways, it doesn't necessarily make budgeting easier. It's a sort of different set of calculations, but I would say 9 times out of 10 tends to work out cheaper. But that is very much based on your application architecture and how you're responding to those requests. And it's also kind of based on what type of application that you have. And so if you're doing really big number crunching and you're a data scientist and you've got some big geodata and you're running lots of queries and computations against it, then a serverless model might not be one for you. That might actually be more time and energy and cost efficient to run that on a local machine or on a cloud, because you're controlling that execution. Serverless really comes into its own when you've got to deal with the demands of scaling up and scaling down. And that scaling isn't necessarily always users. It could be things like IoT arrays, so dealing with large amounts of data coming in. And it could also be dealing with computations when you've got to run a large number of computations in parallel. So, for example, you've got like a machine learning model where you've got lots of things going on and you want to run them simultaneously to be efficient. That's another area where you say, okay, for as long as this execution needs to run, scale out up to 1,000 virtual CPUs and run that process, because that'll be much faster than me trying to chug through it here on an 8-core machine.
So would it be fair to say that in this kind of environment, you're better off, or it makes more sense to be running lots of small executions as opposed to a few really long running executions?
It's really dependent on your application and what your application is trying to achieve. So serverless is definitely not a one size fits all. And I think I should also kind of highlight that there's a large set of different serverless services that exist, and different companies have different offerings. And so I like to think of it in kind of terms of abstraction. And that abstraction is, how far are you getting from the physical machine? So, for example, at Address Cloud, when we have large data sets come in, maybe we're trying to crunch through all of the UK or North America's flood data set, and that might be a flood data set that's at 5-meter resolution. So it's billions of points that we're then trying to extract out and get that into our service. We wouldn't necessarily want to run that in a serverless environment, because we've got a very fixed capacity there. We know that we need to get this job done in so many days, but we know what the data requirements are, and we know what the process is because we've created it. We're not dealing with any unknown kind of scalability of scaling up and scaling down. And we're dealing with something that we know about quite well. And so in that environment, we're just going to go and rent some servers for a while that have got high capacity, fast disk, and we're going to kick off that process on the command line and get on with things. It's when you've got unknown processes, such as a variable number of users or a variable number of sensors or a variable number of data queries, that's when you want to start thinking about, okay, how many short-lived compute sessions do I need to get that piece of work done? However, there's also, so coming back to this idea of this grades or abstractions of serverless, there are some serverless services which are still quite highly managed by the user, where you might say, okay, I think I need 2 or 3 machines with the opportunity to add another one easily later on, all the way through to very abstract environments where you might have a document database, for example, that sits in the cloud, and you have no concept of how many machines sit underneath that database. It's completely abstracted from you. It just allows you to put data in and get data out, and you might pay by number of thousand requests to get that data out, for example. So really, there's no one size fits all. I think that coming back to sort of my original point on geospatial, serverless for geospatial, it's really those 3 kind of use cases of got large data sets coming in from lots of different sensors, be those people or physical machines. We've got large numbers of users submitting queries or trying to look at our maps to understand what's going on in real time. Or I've got a fairly short-lived task that I want to run that's highly parallelizable.
Yeah, after hearing that, I completely understand what you mean when you say there's no one size fits all. It sounds like it's an incredibly flexible architecture. And I guess, too, that depends on which provider you're working with in terms of which architecture you could use and how these packages are put together. Can you give us an idea of what it looks like to publish a service? Is it something like, well, I write a piece of code on my own machine and then publish it to the cloud? Is that what it looks like? Do I log on through some sort of remote desktop and then build my service there or my function directly on this architecture? Or do I interact with it with the serverless geospatial environment through APIs?
I think the answer is D, all of the above.
I was afraid of that.
Really, yeah. So cloud providers are trying to make this as easy to consume as possible, and so they're providing a whole range of different ways for you to access. So let's look at a typical geospatial application. Let's say we've got a PostGIS database which has got some spatial data in it. Let's say we've got some application, a server-side application that's allowing us to query that data. And let's say we've got a website with a map on the front end. And as we move around the map, we're querying that data. And we're all kind of familiar with that paradigm, be it using Google Maps or looking at Airbnb or checking out what time the next train's coming, for example. So in that kind of environment, let's start with the database. And so we've got a database in the back end. Now, what's really exciting to me is Amazon in particular have really forged ahead with the concept of having a serverless database. So they now offer a service called Amazon Aurora, which is a PostgreSQL compatible database. So people working in the spatial domain often use PostgreSQL and the PostGIS spatial database tooling. And so I'm hoping that the listeners are fairly familiar with that. And so Amazon now offer PostGIS effectively as a serverless database. And so what that's saying is you connect to it just like you would connect to any other PostGIS database using using QGIS or using pgadmin. So you've got a connection endpoint. But what's actually sitting there is Amazon's magic that says, as the number of people connect to that database, or as the number of queries goes up, as I challenge the CPU that's available to PostGIS, as I ask for increasingly complex geospatial queries, that database behind the scenes is actually going to scale the number of clusters that's available and make that look as if it's one really big database. And that happens seamlessly, and it happens outside of your control. And so that means as more and more people are asking for requests to my database, querying how many points, where's my nearest bus stop, or how many Airbnb vacation properties meet my search query in this bounding box, that spatial database can scale to meet the demands. What's even more exciting is that tooling allows that database to scale down to no compute capacity when no one's using it. So what that means is your data is safely stored. So you're still paying for the data that you're storing in that database, but you're not paying for any PostgreSQL runtime when no one's using it. And so if you think about a development environment where maybe you're developing during the day and then all of your developers go to sleep, that potentially has quite a big cost saving. And in the morning, when you connect to that database again using QGIS or pgadmin, there's a 60-second delay whilst that thing warms up, and then it's good to go. It's ready. It's on for the day, and it will scale in demand. So that's an example of a serverless data store. So we've already got something out of the box where we can use our existing geospatial applications and technologies. Everyone that's familiar with PostGIS will know how to connect to that database and query it and integrate with it. Moving up the stack, we've got our server-side application layer. Typically would be running on a server traditionally. So, and there are still some good use cases for that, where maybe we want a full-blown application stack out the box, so something like GeoServer or even GeoDjango. Those environments still require, a physical server or virtual server to exist. But let's say in this example of I want to find the nearest train station from my house. That's really quite a simple spatial query. So I need to take in the user's XY, their latitude and longitude, and I need to send my query to my spatial database, which is waiting to receive my connections. So that's quite a simple SQL query. So I could write that in Python, or I could write that in Node.js, or I could write that in lots of different languages. But I'm just going to write that as a one-off function, and I can do that through any kind of text editor. And I upload that as a zip file into the cloud, and I say, when I request to this API, run this function. Take this XY input and go find in the database the nearest train station from this XY input. And then on the front end, we've got a map application. And again, and this is probably the we're approaching now the most abstract level of serverless, if you can imagine that, where we're completely abstracted away from the compute environment that's running our service. So we've got a map on a web page that's allowing us to put in my location and send that location as XY to understand where the nearest train station is. Now, traditionally, again, that web page would have been served by a web server, so it would something like Apache, quite a traditional architecture. What cloud environments now offer is if you've got a single page application, so some JavaScript that renders that map on the user's machine, you can run that in a completely serverless hosted environment where there's no concept of servers at all, but you just say, this is my website, please have it always on, and it's always listening for people to visit my website, www.findmytrainstation.com. And that just sits there in the cloud, and it can even be seeded out around the world or to specific regions that you're interested in. And it will always be on, and it will always resolve. And so there's no concept of scaling up and down there at all. You're paying for the number of people that make requests to that website. And in return for that, you're getting an always on, highly available, highly resilient service. And that's kind of the front end application. So there I've really kind of walked you through how we might think about what could be sort of a traditional geospatial application end to end sitting on the web. But each of those modules, we might want to start to understand, our client side, our server side, our database, how we can start to convert those into a serverless architecture. And we don't have to do it all at once either. That's, if you've got a really big application stack, and this is the case with some of the projects that I've worked on the flood mapping projects, we've got, a really complicated set of tools that are collecting feeds about social media from lots of different data sources, from Facebook, from Twitter, from Telegram. People are sending us all of these reports. We've got emergency services connecting to that data set in real time to understand what's going on. They're publishing maps in real time using the service. So we've got a lot of architecture there which we might not want to change because we've got lots of people who are bought into that service. But what serverless allows us to do is start to chip away at that monolith and say, okay, well, let's take the database. It's our bog standard PostGIS, PostgreSQL database. Let's put that in a serverless data store so that we know that it can deal with the capacity, and also we're not paying for the compute when no one's using it. So that's a pretty long answer, but I think gives a pretty good overview of sort of the state of serverless for Geo as it is today.
Yeah, it was a long answer, but it was fantastic. I mean, I really enjoyed that because you really painted a picture for me anyway, and I'm sure also for the audience. I want to pick on a few points there just to sort of go a little bit deeper and make sure that I've understood the concept. Firstly, I want to say that does sound really exciting, that idea that a Postgres database can just exist in the cloud and that you can just connect to it from your QGIS, for example, and desktop. I think a lot of people, when they think about serverless geospatial or these kind of architectures, they think this is just for web applications. This is just for stuff that exists solely on the web. But what you're saying is this could be that this is basically a hosted database that can scale infinitely, and that I can connect to it using my desktop environment. So I thought that was really cool. And also like that idea that you can break apart your stack, look at the pieces that need to scale and then sort of pull that apart, tease that apart, and port that over to a serverless environment. I thought that was really smart and really exciting. I'd be interested to know, are there any sort of tricks and tips you could give us here in terms of breaking apart a stack? What kinds of things should we be thinking about moving over to a serverless environment first? Is it the database? Is it the web server side of it? Are these specific functions that should be in a serverless environment?
I think there are certainly challenges with undertaking the process that I've described. It doesn't happen overnight. I think there are two key kind of lessons that I've kind of learned and that I try to apply sort of wherever we go with this. So the first is that there's definitely some low-hanging fruit. So the latest offering of being able to use something like PostgreSQL database that's serverless is really, really exciting for the geospatial community because it means we can lift and shift our existing spatial data store really quite quickly and quite easily. That again, the caveat is always that it might not be perfect for every application, but I think for a lot of applications it is really exciting. So I think first step is identifying which bits can you move without too much disruption. And then the second thing is the other kind of sort of low-hanging fruit is getting the web content. If you've got a single page application, now I'm not a front-end developer, but listeners can go away and look this up. But if you've got a single page application with a leaflet map or a Mapbox map, you can really quickly put that in a CloudFront distribution, as AWS terminology calls it, where instead of paying for a web server to have your website on, you're serving that out of a content cache. You upload that website to a data store, to a bucket, and then you say, this is my website, just go away and do your thing. And I think that those two things, so that sort of the very front end, the client application, if you've got one, and then the data store, the database, those two are now becoming almost standard technology and quite easily accessible. I think the middleware is always more challenging, right? Particularly in geospatial, where we've got lots of complex stuff potentially going on. And so I think that needs a little bit more thought, whether you can think about breaking that application up into lots of smaller functions. Can you take away part of that application? Is there part that is highly scalable, that's simple, and so you can just start doing part of it and say, okay, this API endpoint, this set of routes where lots of users are accessing this or querying this data, we're going to put that in a set of functions so that it scales. So it's really dependent on the architecture that you've got. So back to this idea of no one size fits all, but it's about, I think, for the geospatial community, understanding that this technology is now maturing. It's matured quite quickly, and it's continuing to advance. And I think that there's an awful lot of opportunities there to make to break free from what were traditional kind of monolith applications that were hard to scale and quite expensive to run.
I just want to stay with the Postgres database just for a second here. So when you say that is available in the cloud, in these serverless environments, does that mean that the models that we're used to working with, they are available? Or do I also have all those functions available? And the reason why I'm picking on this particular point is earlier in the conversation you talked about, okay, so this is available as a standard feature in some of these environments, but then you also mentioned that you could write your own functions and upload them as zip files, and then have an API say, every time I call this API, call this function here. Does that mean that I can't access the standard functions in Postgres and I have to write my own?
No, not at all. And I think what we're sort of teasing out here is one of the challenges of serverless technology is the terminology and the mix of terminology being applied to different things. So you've got your PostGIS functions that are in there. You can access all of those functions right through queries. You can do your ST intersects as you normally would. That's still there, and it's something that we use every day. When I was talking about our serverless functions, I'm specifically referring to small functions that are executing when I'm asking them to. So, for example, an Amazon Web Service is Lambda. That I've written a bit of code to say, take the user's lat long and send it down to my database and get me the results and give them back to the user. So the functions are typically synonymous with the middleware layer, what traditionally was our GeoServer or our some other web server application code.
Yeah, I'm really pleased you mentioned that about middleware and you came with a definition there. So let's stick with GeoServer. Can you see this being replaced? Can you see something like this being offered as a standard piece of this package in a serverless environment in the future?
Potentially. I think that what GeoServer offers out the box is as an open source bit of kit is incredibly powerful. And allows you to get up and running really quickly, and obviously provides those kind of tooling, provide people with an off-the-shelf stack that they can use. And I think that's great, and I think that there will always be a place for that. The place that I see serverless fitting at the moment, I think this is probably going to change in the future, but at the moment it's still geared towards a developer focus, sort of a bespoke application. We've got some addresses, and we need to be able to let our customers do a batch process of 1 million addresses a day, and we need to be able to handle that without a sweat. And geocode them all and send those results back. And so there we've got a discrete application that we've gone away and built ourselves, because that's our secret sauce. So I think that something like GeoServer could always benefit from thinking about maybe running part of that in a serverless environment. So if you've got a GeoServer stack, can the database, for example, be run serverless? What's the integration look like there? And then the thing that we also haven't talked about really is containerization and Docker. People often sort of get the two confused. But really, Docker and containers are really a halfway house between physical compute and serverless. So I wouldn't say they are serverless, because you're still managing the underlying hardware. You're just saying, I've got this, I've got 4 physical servers or virtual servers in the cloud, and then I've got lots of little containers that turn on and turn off that sit on top of that. If we can run GeoServer in an environment like that, in a containerized environment, that takes away some of the pain of having to manage that infrastructure. And allows us to be more scalable, albeit with the constraints of managing that infrastructure. So that's why you see that large enterprises are still really excited about the containerized space. which I think over time will go away as cloud providers get better at offering serverless infrastructure that allows us to do something like GeoServer out the box. It's serverless in the cloud immediately. We're not there yet, and so that's what containers offer, that halfway house. I think if you're coming into this and you've got an idea for an application, or you've got an existing application and it's your application, it's got your magic inside it, you've written it, you know what's going on in that middleware layer, you've got those PostGIS queries, fine-tuned, and you're offering that to a number of users over the web through an API or through a map that backs onto an API. I think at the moment, those are the kind of applications that are ripe for thinking about, okay, how can I break this down? How can I get this to be serverless? And effectively, it's saving time and money, getting away from worrying about waking up in the middle of the night, are my servers on? Is everything working? To, I'm paying for that capacity to be provisioned as and when I need it.
Now, I think you alluded to this before, but when you look out to the future of this, do you see any really big trends that we should sort of keep an eye on as geospatial professionals?
I think there's two things. In the sort of short to medium term, I think that developing geospatial applications with serverless architectures will be easier as the tooling advances. At the moment, there are a number of competing methods to develop your serverless application. There's a technology or a group of technology called infrastructure as code, where you define your infrastructure as a series of code files. And that existed before serverless, but has really come into its own with serverless environments, where you've got lots of small functions going on. And that's a really good way to manage and to organize your system and your architecture. And so those technologies are becoming easier and easier and more accessible to use. So I think that creating that application, that idea that you've got using serverless technology will become the norm. And then I think on the longer term horizon, I think, it's taking that off the shelf application. I saw a really good example at Phos4G UK up in Edinburgh last year. It was someone that was speaking just before me, and they're gonna hate me because I've forgotten the name of the company, but they were running QGIS in the cloud, connecting to it remotely through a web browser, and that was running serverlessly, so that they were doing training sessions with hundreds of users in the classroom all at one time, and rather than going around and installing QGIS on everyone's machine, with all the problems that we know that can entail, as everyone's got a different device or a different operating system, they had the standardized cloud-based system, which was completely scalable, and so their application was, the entire application was running in the cloud. And so I think that will come over time, being able to take our existing off-the-shelf geo applications, the open source geo applications that we all know and love and that we use day in, day out, being able to run them in a way that is scalable and is going to deal with demand in the future.
Thomas, I really want to thank you for taking the time to explain some of this stuff to me personally and to the audience. I really appreciate it. I find it fascinating, even though I'm very much a beginner in this space. It's been a really enjoyable conversation. Before I say goodbye, where is it that the listeners can go to contact you, to reach out to you, or to learn more about your work?
Probably the best place is to head over to addresscloud.com, and then actually for more technical details, go to blog.addresscloud.com, and there's some contact details on there. I'm also on Twitter, and my Twitter handle is @iholdeness.
Thanks again. I really appreciate it.
Thanks, Daniel. That was great.
Thanks again to our sponsor, OpenCageData. The team behind this geocoder does an incredible amount of work for the geospatial community at large, and they have been incredibly supportive of this podcast. So if you have any geocoding needs, I'd hope that you would consider them. They are a fantastic team, it's a great product, and the service level is incredible. So if you need geocoding, check out OpenCageData. You can support us by supporting them. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I am so grateful that you tuned in again this week. It's much appreciated. I'm also incredibly grateful for the people that are sharing this podcast on social media. The comments are fantastic, and I really appreciate the interaction. This also gives me a chance to sort of understand who's listening, what they're listening for, what they like, what they don't like, and it's a huge opportunity for me to improve. So the shares on social media, the comments on social media are much appreciated. And that's it for me. I'll be back again next week. We'll talk then.